Today we are going to be adding and subtracting monomials. So let's figure out what these monomials are first. Well, when we look at the prefix mono, mono represents the number 1. And so if I'm talking about one term, I'm talking about a number. It could be even a negative number. It could be a fraction. And any fraction you could write as a decimal. And so it could be any of these values, but it could also be a variable. It could even be a number and a variable multiplied. It just cannot have a number and, let's say, a variable being added or anything being added. So that would not end up working out. But these all work out. We could also have a variable to a power, like 9x squared. The criteria, though, says that you can't have a negative exponent. So you can't have something like 9x to the negative first power, because this would be the same as 9 over x. And again, when you have a negative exponent, it means you're dividing by a variable. And that's one of the rules with monomials. You cannot divide by an unknown. So those don't work out. But any of these other combinations do. One other one is that you could have a number, let's say it's negative. It could be a negative number, just as I had over here, and we could multiply by a series of variables, even to positive exponents. So those are the criteria. That's what a monomial is, and what we're going to be doing is adding them together. So we look at this one here. We've got 7a squared, and I'm going to combine it with the negative 9a squared. So I'm using that commutative property. And when you look at the word commutative, we see a word in there. It's the commutative property of addition. You see this word commute in there, and commute means to move, and that's what we are doing here. We're using that moving property. So I'm going to take the 7a squared, and I'm going to bring that negative 9a squared right next to it. And then I'm going to rewrite that positive 5a. Now notice that these are opposite in sign, so I'm going to end up subtracting these two numbers. And notice that I don't change the exponents, I'm just changing the coefficients. Coefficients are those numbers in front of the exponents. And so my answer would be a negative 2a squared plus 5a. And I like to write it this way in what I call descending order. So descending order means that it's going from the highest exponent down to the lowest exponent. And so notice here I have the highest exponent on the variable is 2, and then it goes to the next lower one, and this one would be 1. And if I had a number without a variable, that number, which we call a constant, goes last. So we'll try getting it in the same order. It makes it easier for the reader to grade, and then also when we get into factoring, it makes it easier to factor later on. So let's take a look at the next one here. Here we have nothing to combine with this 2 and 5/10 a to the fourth. There's no other a to the fourth here, but we do have some common terms. We've got a positive 8 and 1/10 b to the fourth, and a negative 3 and 6/10 b to the fourth power. So I'm going to collect those two terms. Since they're already right next to each other, basically I'm using another property. I'm calling this the associative property. I'm grouping these two terms together. So that's the property I'm using here. It's the grouping property, and they call it the associative because an association, if you look at this word right here, associative, right here, if I change this to an ION, association is a group of people. And here we are grouping terms. Now we're using the associative property of addition. And anytime we've got a subtraction problem, we can change it to addition like this, plus a negative, and I just collect those two terms. So I'll go ahead and bring down my 2 and 5/10 a to the fourth. And when I look at this, I'm subtracting these numbers. So off to the side, you might want to write down 8.1 minus 3.6. And when we do that subtraction, I need to borrow from that 8, change it to a 7, and that makes 4.5. So 4.5, there's more positives than negatives, so that's what it is, a positive 4 and 5/10 b to the fourth power. And that's it. So as I said before, descending order is what we do. Well, here the exponents are the same. So typically you look at the variable that comes first in the alphabet, so a in this case, and we go with its exponents. So since this has no a, we just put that one last. Well, another example here, we've got, nothing we can combine. So we don't have any variables with the same exponent. but we do have two constants. Let's go ahead and collect those. We can make this a little simpler. So you see how these two terms have just a constant. We say that we could write down x to the 0 power if we wanted to, because that just equals 1. And 1 times negative 3 still makes negative 3. So let's go ahead and use that commutative property, bring those numbers next to each other. So I still have that 3x to the 4th, the minus x to the 3rd, and always remember to commute the sign with the term. And then I've got a negative 4 and a negative 3. So I go ahead and multiply. So I'm not multiplying, but adding these because they are the same sign, and I end up with a negative 7. So I just bring everything else down. 3x to the 4th minus an x to the 3rd. And there is our answer. Well, the next problem just has more variables involved in it. And so here we look for the common factors that we can combine with. And I see that I have a 7x squared y squared. And over here, this isn't quite the same. It doesn't have the squared symbol on the y. So we have to continue further. Oh, right here. Here's another x squared y squared. So those two I'm going to collect together. And so when I do that, I end up getting a 9x squared y squared. So I just moved them next to each other and then added them together. So x squared y squared, x squared y squared. I had 2 of them here, 7 of them here, makes 9 altogether. Let's take a look at the next type here. We've got a x squared y. Do we have another x squared y? Sure enough, we do right here. So it's a positive x squared y. This one's a negative 4x squared y. So watch the sign. See how there's more negatives than positives? Since they are opposite in sign, we are subtracting. Now it's going to be a negative. Now what number do you think it's going to be? Negative 4 plus 1. Well, that would make a negative 3x squared y, and that would be our answer. Well, we can't combine them because they don't have the same exponent on the y. Well, let's take a look at the next one here. We've got a c to the 4th, a 3c to the 4th. So this term right here, we're going to collect with this term right here. And they're opposite in sign, so I'll end up subtracting. Let's just write them next to each other. 3c to the 4th minus c to the 4th. Let's bring some other terms together. So we look further, and I see that we have a negative 2c. Over here I have a negative 2c. So I'll write those next to each other. Negative 2c minus c. And then my last term, well, my last term is this negative 1. So I'm going to write down minus 1 right here, and then I just collect. And so I see that this makes a 2c to the 4th. And over here, these are going to add together. They're the same sign, so it's still negative, but it's negative 3c, because it's a negative 1 minus 2 makes negative 3. And then bring down that minus 1. There is our answer. Well, one more problem to practice. Let's see if we can come up with the answer. Well, first of all, we look for x squareds. Here's 1. And I have 1 over here. Now look at the sign. It's a negative 4x squared. So I've got an x squared minus 4x squared. And now let's take a look at the other component. We have a x term here, so a positive x. And here we have a positive 3x. So I'll put plus 3x. And then I grouped them together already, so let's go ahead and combine. Here I have 1x squared minus 4x squared. They're opposite signs, so I subtract negative 3x squared. Over here, they're the same sign, so I'm going to end up having to add. It makes a positive 4x. And there is the answer. Well, those are some of the problems you'll see on tonight's homework. Good luck.